Now in this video, a pentagonal lamina having edges 25 mm is placed on one of its corners on HP, such that the perpendicular bisector of the edge passing through the corners on which the lamina rests is inclined at 30 degrees to HP and 45 degrees to VP. Draw the top and front views of the lamina. So this is the problem which is given to you, how to solve this problem on projections of laminas by analyzing in 3 dimension, but also how to solve it manually. So to do that, first he says it is placed on one of its corners on HP. So that means whether the edge is resting on HP or the corner is resting on HP, in pentagon, that is the odd number size, always the edge has to be perpendicular to VP. And you have to solve the problem by considering from the horizontal plane, that is the top view. So we need to start the problem from the top view. So how to do that? Now first we will go for the initial position. So here a pentagonal lamina. So first we need to write a pentagon such that the surface is made parallel to HP, and then parallel to HP, and the surface is perpendicular to VP. Since the surface is perpendicular to VP, you are getting a line in the front view, and as the square, all the sides are parallel to HP, so you can see the true length in HP. So what is the true length? True length is 25 mm, and when you look from the top view, all the 5 points are visible, and one of the perpendicular bisector, which is the perpendicular bisector from the corner to the opposite edge, is the perpendicular bisector. Only CM is the perpendicular bisector which is parallel to VP. If you consider any other perpendicular bisector, that is from A to the midpoint of BCD, again that line will going to become inclined. Similarly, B perpendicular to this CD, ED means that is inclined to VP, and D to AB. So the corner to the opposite edge, midpoint, the corner opposite to the edge, which is the midpoint, is the perpendicular bisector. Only this perpendicular bisector is parallel to VP. Therefore, you are getting the true length in VP. So that is the reason why we are considering this perpendicular bisector and omitting all other perpendicular bisector. That is a perpendicular bisector from A, B, D and E. If you consider E, the perpendicular bisector is the midpoint of BC. So again that is becomes inclined to VP. So therefore we will not consider all these perpendicular bisector except the one between C and M. So as you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible, and D and E is away from the observer, so D dash is in bracket, E dash is in bracket, and of course M is also on the edge between A and E, so that M dash is also becomes invisible. So once you do that, now we will go to how it can be written in the sketchbook. So first we will go to draw the XY line, and you mark VP and HP, and you measure 25 mm on the sketchbook on the grid, and you draw a line of 25 mm, and you mark this point as A and E. Then by using the protractor with A center with respect to AE, you measure an included angle of 108 degree and then draw an inclined line. Similarly, with E center with respect to EA, you measure an angle of 108 degree, which is the included angle, then draw an inclined line. Then by using the compass with A center, take the radius of 25, cut on this 108 degree line. Similarly, with E center, take a radius of 25 and cut on this 108 degree line, and you mark these 2 points as B and D. With B as center, take the radius of 25, you draw an arc. With D as center, take a radius of 25, cut an arc on the previously drawn arc, and you mark that point as C. Then join A to B, B to C, C to D, D to E and E to A with a dark line. Then from C, you draw a horizontal line which is perpendicular to EE, which will automatically becomes the midpoint of EE. Then you mark that point as M. Then from A, E and M, draw a vertical projector to the XY line. Similarly, from B and D, you draw a vertical projector to the XY line, and also from C, you draw a vertical projector to the XY line. As you look from the front view, ABC is near to the observer, Therefore, A dash, B dash, C dash is visible. D, E and M is away from the observer. Therefore, D dash, E dash and M dash is in bracket. Then join A dash to C dash with a dot line. So this is how you will be able to write the initial position of the top view and front view in the first position of the pentagonal lamina. Now, he says the perpendicular bisector is resting on one of its corners on HP, and the perpendicular bisector of the edge passing through the corner is inclined to HP at 30 degrees. So which is the perpendicular bisector? That is CM is the line which is inclined at 30 degrees to HP. So we are rotating this entire pentagonal lamina by keeping the corner on XY line, and you are rotating that by an angle of 30 degrees. So what is the position of this surface of the lamina with respect to HP and VP? The surface has become inclined to HP, that you can see in the front view here, which is inclined at the entire surface has been inclined to HP at 30 degrees. And as you look from the front view, all these are projected to the vertical plane. So since you are rotating the same pentagonal lamina by an angle of 30, therefore the image is also getting rotated here at an angle of 30 degrees. So whatever the view you have here, the same view will continue here also. And then when you look from the top view, from A you draw a vertical, the image is falls on HP. From B also, similarly from C, D and E and F. So this becomes the pentagon again. You can see that as the perpendicular bisector has become inclined to HP, so what happens? This CM will going to become the apparent length. You can see this length will not be equal to this length here. So that is why it has got the apparent length. So this is the one. What is the position of this pentagonal surface with respect to both HP and VP? With respect to HP, this surface is inclined, and with respect to VP, it is perpendicular. Therefore, you are getting a line in the front view, and this is the angle which is inclined at 30 degrees to HP. Now, how to do this when you are in the orthographic view in the sketchbook? So take any convenient distance with respect to this point, and you mark that point as C dash. By using the protractor with C dash as center, with respect to the XY line, you measure an angle of 30 degrees in the clockwise direction, and you draw an inclined line. By using the compass with C dash as center, take the radius of C dash A dash with C dash as center, cut it on the previous, that is 30 degree line, and you mark this point as A dash, then E dash in bracket, then M dash in bracket. Then you measure the distance from C dash to B dash with C dash as center, cut an arc on that 30 degree line, and then you mark that point as B dash and D dash. Then join A dash to C dash with a dark line. Now I need to write the top view. So how to write the top view? Draw a vertical projector from A dash, E dash and M dash, and draw a horizontal projector from A and also from M and also from E to this line, and you mark this point as A, M and E. Similarly, you draw a vertical projector from B dash and D dash to the top view, and draw a horizontal projector from both B and D. Both these two lines will going to intersect at these 2 points. You mark these 2 points as B and D. Similarly, draw a vertical projector from C dash and draw a horizontal projector from C. Both these 2 lines will going to intersect at this point. You mark this point as C. Then join A to B with a dark line, B to C with a dark line, C to D, D to E and E to A with a dark line. So as we rotate this C dash M dash with inclined to HP by 30 degrees, obviously this CM will going to become the apparent length. The meaning of this is the length of CM in the second position top view will not be the same as the length of CM in the front view, in the first position top view. So that means this length will be greater and this length will going to be smaller. So this is how you will be able to write the second position front view and also the top view. Here in the second position, A dash, E dash is parallel to HP, so you are getting the true length, and all other sides are being inclined to HP, therefore all other sides will not be in true length. And now this is how you will be able to write the second position. Now we will go to the third position. So here what he says, that the perpendicular bisector of the edge passing through the corner on which the lamina rests is being inclined to VP at 45 degrees. So that means we need to rewrite the second position top view here. But that angle what he has given here, this 45 degree, is the true inclination line. So first you need to draw a true inclination line of 45 degree. Then since it is the true inclination line, you have to take the true length of the top view. Where is the true length of the top view? Here, which is C and M. Because CM is C dash, M dash is parallel to HP, so you are getting the true length here. You measure the length from C to M with this point as center, cut an arc on this line, that is 45 degree line, then you draw the locus line. Then similarly, you take the distance from C to M of the second position top view. From C, you cut an arc on this locus. So you got CM now. So then you reorient this inclination onto this, so that you will going to get this point will going to become M. So then this is the position where you will going to get the third position top view. And as you look from the top view, D is projected onto HP, B is projected onto HP, A and E also has been projected onto HP and also with respect to M. So then what happens? Then you get the top view, third position top view on this beta inclination line. You can see that here. Okay. So when you look from the front view, this C dash is here and B dash and D dash is here, and A dash and E dash is here. So once you get that, so this is the final position of the front view in the third position. That means even in the final position you can see that C dash is on XY line, that is the corner is on XY line, and the perpendicular bisector which is passing through the corner on which the laminar rests is inclined at 45 degrees to VP. So we need to find the beta inclination. So for that you need find out that beta inclination. Then the surface is inclined at 30 degrees to HP, and this is a pentagon of 25 mm side. So this is how you will be able to analyze the problem in 3 dimensions. Now how to do that, the third position front view or top view now. So here first we are going to consider any point and draw a horizontal line with respect, and you mark that point as C. With respect to that point C, with respect to the horizontal line, by using the protractor, you measure an angle of 45 degrees and draw an inclined line. Then, since this is the true inclination line, so from the projections of lines, I have to transfer the true length of the line on the true inclination. So where is the true length of the line? The true length of the line of the perpendicular bisector is here, which is C to M. By using the compass with C as center, taking the radius of CM, and with same C as center, cut an arc on that 45 degree line. So you got this arc. Then from this point you draw a horizontal line. Then you take the apparent length of the second position top view, because C dash M dash is inclined to HP here. Therefore you will going to get the apparent length here. By using the compass with C as center, take the radius of CM in the second position top view with the same center in the third position top view, cut an arc on this locus line. So you mark this point as M. Then through M, since through M, this AE is perpendicular to this CM line. So by using the protractor with M as center, with respect to this CM line, you draw a perpendicular. Then you measure the distance from M to A, which is same as M to E. With M as center, cut an arc on this perpendicular line on towards this side and also on towards this side. You mark this point as A and you mark this point as E. Similarly, you measure the distance from C to this point and transfer from C to this point here. Then through this point, with respect to CM, you measure an angle of 90 degrees and draw the perpendicular line with respect to CM on either side. Then by using the compass with this as center, take the radius of this point to B and also from this point to D. With the same center here, cut an arc on this side and also on this side. As we are rotating this second position top view in counterclockwise direction, B will come on this side and D will going to come on this side. Then join A to B, B to C, C to D, D to E and E to A with a dot line. Now we need to write the front view. So to do that, draw a horizontal projector from the second position front view to the third position. Then you draw a vertical projector from both A and E to the front view and mark these 2 points as A dash and D dash, and draw a horizontal projector from B dash and D dash and from the second position front view, and draw a vertical projector from the third position top view to the front view, third position front view. These two lines will going to intersect at these 2 points. You mark them as B dash and D dash and draw a horizontal projector from C dash to the third position front view, and draw a vertical projector from C to the XY line, and you mark that point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and E dash to A dash. So this is how you will be able to write the third position, both the top view and front view in the sketchbook. So how do I know that my problem is right? You can see that even in the third position, the pentagonal lamina is resting on one of its corners on HP, and the perpendicular bisector passing through the corner on which the lamina rests is inclined at 45 degrees to 45 degrees to VP. So since he has given the true inclination, we need to find out the beta inclination. So we have found out that here the perpendicular bisector is inclined to HP at 30 degrees, and you have a pentagonal lamina of 25 mm side. The pentagonal lamina of 25 mm will going to be the true length of the pentagon. Since we have incorporated all the data which was given in the problem to solve this problem, and hence the problem is right. Thank you.